In this video, I will be explaining exercises concerning polynomial factors and graphs. As question 1 states, p of x is equal to 2x cubed minus 18x. Given the polynomial function p defined above, what are its zeros? So the zeros are the values for x that make my polynomial p of x equals to 0. Thus, we need to solve here for 2x cubed minus 18x equals to 0. Factorizing this out, you will get 2x as a common factor. You will be left with x squared minus 9 equals to 0. Going forward with our factorization, you can write x squared minus 9 as x minus 3 into x plus 3, which gives me my solutions to be x equals to 0 from this one. From here, I will get x minus 3 equals to 0, which gives me x equals to 3. And from the last one, x equals to minus 3 is a solution. Thus, my solution for such an exercise is the choice part D. Next, in exercise number 2, which of the following functions could represent the graph at right in the xy plane where y equals to p of x? Now, if we look at this graph here, our zeros for this graph are at 0, x equals to 0, so that's one of my solutions, and at two values that are in the negative side of the y-axis. So it's on the negative side of the x-axis, thus my solutions or my zeros should be equal to something that's negative. Now, knowing that one of my zeros is x equals to 0, thus p of x should be divisible by x. And choices A and C are not of this form. Thus, we need to cancel out those two choices. And we will be left with choice B and D. Factorizing those two, you would get x into x squared plus 6x plus 8 and x into x squared minus 6x plus 8. Now, those two are factorized into the following two forms. So x into x minus 4 into, x plus 4 into x plus 2, and x into x minus 4 into x minus 2. So this is for choice number B, and this is for choice part D. Now, remember, our solutions had to be negative. Thus, this choice gives me positive roots, and it's not the case, whereas choice B gives me negative roots, which are x equals to negative 4 and x equals to negative 2. Thus, it is the case, and my solution would be choice number B. Now, exercise number 3. A polynomial has zeros at minus 9, 2, and 0. Which of the following could be the polynomial? Knowing that those are my zeros, then my polynomial could be written as x plus 9 into x minus 2 into x. And it could also be a multiple of such a polynomial, so there could be a constant a here. But disregard this constant for now. Let's distribute this equation. You will get x squared minus 2x plus 9x minus 18 into x. I will keep here the a for later on. Now multiply this x inside here. What do you get? You get a into x cubed minus 2x squared plus 9x squared minus 18x. Simplify those two, you will get x cubed plus 7x squared minus 18x, and you still have this a. This a could be any value. It doesn't depend on anything, but if you think of the choices that you have here, it's not going to be choice A, nor C, nor D. Thus, our only case here is when A is equal to 1, and my solution is part D. Question number 4 now. X minus 7 into x plus 5 into 2x minus 3. Given the polynomial above, what are its zeros? So its zeros again are the values for x where all of this polynomial is equal to 0. Thus we need to solve for this polynomial equals to 0, which will give me x minus 7 equals to 0, thus x equals to 7. This is one of the zeros. We have x plus 5 equals to 0, which gives me x equals to negative 5, and 2x minus 3 equals to 0, which gives me 2x equals to 3, so x is equal to 3 over 2. Looking at my solutions here, or my choices, my only case is when the roots are 7, negative 5, and 3 over 2, which is D. Finally, exercise number 5, which is really similar to the one we just solved. Given the polynomial above, what are its zeros? So we need to equate this equals to 0. We'll get x plus 55 equals to 0. Let me fix this 5. So x plus 55 equals to 0, and x minus 17 equals to 0, which obviously gives me x equals to negative 55 and x equals to 17. Thus, my answer is choice number A.